Now, in our last class, we have ended up with token ring protocol. Now we know now that both the CSMA-CD protocol and token ring protocol, and these two protocols are needed to send an information in a local area network, and it tells us how each node connected in a local area network will share the information amongst each other, and by following the rules they are going to share the information amongst each other, and that two protocols are CSMA CD protocol and token ring protocol. So the MAC layer protocol in LAN protocol architectural layer, it is responsible for telling the users how it will access the medium to send the information between the nodes. Now, above MAC layer, which is medium access control layer, we have a LLC layer. So the logical link control layer, and it is a higher layer besides why we call this to be a higher layer, because it is above medium access control layer. So that is why the function of the logical control layer are the followings. It runs above the MAC sub layer. It will receive the data from the higher layer. That means we have in LAN protocol architecture, what we have seen, the bottom layer is the physical layer, and the next layer is the data link layer, and data link layer is divided into two layers, and these two layers are medium access control layer and logical link control layer. So this is the second layer, and then the third layer is IP layer, fourth layer is TCP, and the fifth layer is or the highest layer will be the application layer. Now that is why above the LLC layer we have a IP layer. So the data received from the logic link control layer, it will receive the data from the higher layer and then assemble the data into a frame, which we call medium access control frame, which is run over the LAN transmission medium that is assembled here. And it also, the function of the logic link control layer is to include error detection code and address of the source and destination LAN, nodes. These LAN addresses are append in this layer. So the function of logically control layer, it is run above the MAC sub layer. Data received from the higher layer is assembled into frames, which we call to be a MAC frame or medium access control frame, and it includes error detection and address fields are added in this layer. Now at the receiving end side, this is the function of the logic link layer at the sending end side, and the receiving end side, the action is just opposite, which means that it will logically control layer will receive data from the MAC layer at the receiving end side, and then the frames are disassembled here. The address is carried out, or address is recognized. That means it will recognize for which node the information is being sent by the sending end node, and error detection if the data received with an error. So that error is detected here, and the LLC layer provides interface to the higher layer. So these are the functions of logical link control layer. And the IP layer transport layer, application layer, these functions we have already studied in when we have studied TCP/IP protocol architectural model. So this is the function of logic link control layer, and we have also studied what is the function of the MAC layer, which is medium access control layer, because in case of LAN local area networking, the nodes that has been connected to the network that contains this LAN protocol architecture. And here in LAN protocol architectural model, data link layer is divided into two layers, which is MAC layer and then LLC layer. So this is all about the functions of the different layers of LAN protocol architectural model. Now we come to the LAN standard. Now the LAN has been specified by IEEE 802 committee, and this committee, for according to these committees, there are various standards for LAN, and these standards tells us what will be the data rate for each standard, what will be the topology for each standard, what will be the medium access control protocol for each standard. And also it decides what will be the transmission medium and what will be the signaling code or what type of digital encoding scheme we are going to use to send the digital data. And according to them, IEEE 802, we have different LAN standard. First one is IEEE 802.3. And here these LAN standards include bus, tree, or star. And here the MAC protocol is MAC protocol will be CSMACD, and the physical layer, because I have already told you, it will decide what will be the signal, what will be the data rate. So if it is a baseband LAN, because I have told you previously that LAN are of two types, baseband LAN and broadband LAN. Baseband LAN will carry the baseband signal without any modification in the frequency spectrum of the signal, and broadband LAN uses transmitting the signal after modulating it with a carrier. Because you have already know what we mean by baseband communication and broadband or carrier communication. So the physical layer of the LAN, that means the LAN transmission medium, it carries baseband signal, and the transmission medium will be coaxial cable, because it will denote what type of medium. Standards also denote what type of transmission medium we are going to use. And the data rate will be 10 megabit per second. For unshielded twisted pair, it will be 10 Mbps or 100 Mbps. Shielded twisted pair, 100 Mbps. Broadband coaxial cable, 10 Mbps. Optical fiber, 10 Mbps. So this will be the uh, physical layer specifications according to IEEE 802 committee, and this standard therefore known as IEEE 802.3 standard. Now if we want to install a LAN in our in any case, according to if we are following 802.3, we have to maintain this. Just like for laboratory experiments, the experiments have been carried out according to Indian standard specifications. Clear? Hello?
Yes, ma'am. Yes, ma'am.
Now 802.3 again have 6 alternatives for 10 Mbps, which is 10 base 5. Here 10 denotes, here first 10 denotes the data rate. Second, base means it is a baseband LAN, and 5 means it will be how long will be the length of the local area network. It is 500 meter. And the signaling technique we used is Manchester, and the topology is bus topology. If it is 10 base 2, which is 200 meter segment length, here again Manchester signaling is used and topology is the bus. And 10 base T stands for twisted pair. 10 is the data rate, base means baseband LAN, and T is the physical medium, denotes the physical medium, which is T stands for twisted pair. And here also Manchester signaling is being used, but the topology here is star. But whereas in case of 10 base 5, 10 base 2, topology is bus. Now there will be a 10 broad 36. That means 10 will be the data rate, 10 Mbps. Broad means broadband LAN, and 36 means 3600 meter length, 3600 meter length end to end, and the or 800 meter segment length. 800 meter segment, that means the 3600 total length will be the total length of the local area network will be for, if we are using 802.3 10 broad 36, then it will be divided into two 1800 meter segment. And the signaling technique here uses DPSK. Have you studied yet PSK? Hello? Have you studied PSK, or have you studied phase modulation yet? Then tell me what we actually do in phase modulation, which is falls under analog modulation. Hello? Now, what we mean by phase modulation? Phase of what? Yeah, phase of the carrier. It is phase modulation. So how could we change frequency? In phase modulation, frequency and amplitude remain same, remain constant. Only phase will change. In frequency modulation, amplitude and phase remain constant. Only frequency of the carrier will change. And in amplitude modulation, frequency and phase remain constant, and amplitude of the carrier is being changed. You didn't understood the difference between AM, FM, and PM. And in PM, you are saying we are changing the frequency. Then how could it be a phase modulation? Hello? With modulating signal, which is the information signal or a message signal. That means in amplitude modulation, what we have seen, the amplitude of the carrier is being modulated with the message signal or information signal, or we call it to be a modulating signal. and the signal what we get after modulation, that signal is known as modulated signal. এই তোমরা কি পড়েছো বলো তো? না মানে পড়ানো হচ্ছে, তোমরা যেহেতু এগুলো মানে নোটসটা পাঠানোর পরে একবারও দেখার প্রয়োজনীয়তাটা বোধ করো না, সেই জন্য তোমরা কিছু বলতে পারছো না। What is this? We are sending you the notes immediately we finish the topic, and you didn't have a time to look over it for a one time only. Hello? সরি ম্যাম বললেই সব হয়ে যায় না। Okay, in DPSK or PSK, it is nothing but a digital carrier communication, where in digital carrier communication, with the phase modulation, which is in analog, is known as PSK. In case of digital, we call it to be a phase shift keying. That means the phase of the carrier is being changed with a modulating signal or information signal, and the message signal, information signal, or a modulating signal. Now in digital, what will be the value of the modulating information or message signal if it is digital? Pardon? I am asking what will be the value of the information signal, message signal, or a modulating signal in case of digital transmission. Nobody knows. It will have a value of either 1 or 0 because it is a digital data, binary values. Digital, I am talking about digital, because all the computer network, in computer networking, all the signals are being digital. এটা তোমাদের কি হচ্ছে আমি কিছু বুঝতে পারি না। আসলে তোমাদের সুবিধে পরীক্ষার সময় তো দেখে দেখে টুকে টুকে দিয়ে দেবে, সুতরাং পড়ার প্রয়োজনীয়তাটা বোধ করছো না। Now that is why we call it a phase shift keying. It is a keying process because key, it has two states only. When there is a key, we have a one value. When there is no key, we have another value. Isn't it? Now, what we mean by differential encoding? Tell me. I have told you about this. What we mean by differential encoding in case of digital encoding, when we have studied digital encoding. Now, tell me. In digital and in differential encoding, where we are going to recognize digital signals by its values or by its change.
By the change.
Yes, yes. Because similarly in DPSK also, in PSK, what is happening, if we are, since it is a PSK, phase shift keying, which is digital version of the modulated signal, or what we call PM wave. PM wave is equivalent to PSK in case of digital communication. So it has, PSK also have two values. Now, since the digital data has two values, either 0 or 1, when we are going to in PSK, when we are going to send 0 digital data 0, then we are using one phase of the carrier, and to send 1 we will change, we will use 180-degree out of phase of the carrier. Say if the 0 is represented by 0-degree phase carrier, and the 1 will be represented by 180-degree phase of the carrier. Now here, since it is differential encoding, so in PSK we are recognizing the change in phase by its values. But where in DPSK, when there is 0, there will be no change. When it is 1, there will be a change in the phase of the carrier. Clear? Now here I told you wrong. Here when change is 0, when 0 occurs, there will be a change in phase. But when no 0, when or 1, when 1 occurs, there will be no change in phase. So we are going to recognize the signal by seeing the changing its phase, not its value. Clear? But I have, we can use either way. We can use 1 for change, or we can use 0 for no change. But here in DPSK, here change in phase occurs when 0 occurs, and no change in phase occurs when 1 occurs. It will remain in the same state. So that is why it is easier for the receiver to detect the change in phase, not to determine the phase itself, whether it is a 0-degree phase carrier or whether it is a 180-degree phase carrier. Clear? Hello?
Yes.
Yes. When there is when 0 occurs, there will be always, say, first 0 will be 0-degree, second 0 will be 180-degree out of phase. Then the receiver will know there will be 2 zeros, and if then after 2 zeros, if 1 will come, then it will be 180-degree, it will remain in the same phase. Clear? Then the receiver clearly distinguish between 0 and 1, because all receiver already know what type of signaling technique the sender is going to use to send the information, because all the informations or the error detection code, whatever we are using, both sender and receiver, prior to information transmission, the sender and receiver will agreed upon that. Yeah, there will be no change if the for 2 zeros there will be change. For 2 consecutive zeros, for each 0 there will be a change in phase in DPSK. But for 1 there will be no change in phase, whether it is in 0-degree phase carrier, whether it is 180-degree phase 180-degree out of phase carrier, the 1 will remain in the same step. If it is 0-degree, if the previous will be 0-degree, when 1 comes, it will remain in same. If it is 180-degree, then it will remain in 180-degree. Clear?
Yes.
Now here, besides the signaling technique DPSK, in case of 10 broad 36, I have told you we have 6 specifications. We have already 1, 2, 3, and 4. Then another 2, it is known as 10 base F. F stands for fiber. 10 Mbps data rate, baseband LAN, and Manchester signaling technique is used, and topology is star. And there is It is a Manchester, but for differential Manchester, there will be a change. For 0, there will be a change. For 1, there will be no change. I have told you previously. It is a Manchester, not differential Manchester. Manchester and differential Manchester are different. What you are asking? It is Manchester, not differential Manchester. Also see it is specification 10 base F. For baseband LAN, we are using Manchester or differential Manchester. I have told you, I have forgotten. Manchester definitely we are used, and differential Manchester sometimes we are used, but not yet we have seen about differential Manchester. And why we are using Manchester, what is the advantages of Manchester encoding techniques? That I have already, it is self-synchronizing. We didn't need bothered about clock. And there are also, it has no DC component. All these are the advantages over other signaling methods. Have you studied digital encoding, the notes that I have sent? Whether have you a look for one time only? Tell me the truth. Hello? Yeah, I know. Now, 1 base T, it is stands for 1 megabit per second, baseband LAN, and T stands for twisted pair. And this is obsolete. We are not using this because we have already get the specifications of higher data rate, and it is that the data rate is low, which is 1 Mbps only. So this is obsolete nowadays. So the LAN, so if we want to LAN incorporate LAN, or according to 802.3 standard, if we want to use this standard, then we have 6 specifications. Now next we have again 802.3. when we need higher data rate, it is 802.3 100 Mbps specifications. It is first one is 100 base T. T stands for twisted pair. F stands for fiber optic. Just like that. 100 base means 100 Mbps baseband LAN, and T is the twisted pair, and here it is a shielded twisted pair. When we are using T, then it will be a twisted pair, but there will be a specifications for shielded and unshielded. Now since we are using, I have told you, if we are using shield, external electromagnetic interference or error due to external interference will bypass through the shield, and it may not affect the actual wire which is carrying the information, so the data rate will be high. And here using MLT3 signaling technique, we have again 100 base T unshielded twisted pair. Here we are using Cat5 UTP and MLT3 signaling technique. So LAN standard IEEE 802 committee has specified what type of topology, what will be the transmission medium, what will be the data rate, what will be the signaling technique when we are going to install LAN anywhere. And if it is fiber optic, the data rate will be since 100 base, this will denote the data rate, this will denote the type of the LAN, and this is F for fiber. And here NRZI signaling technique is being used. Non-return to 0, inverted on 1. Again NRZI, it is a differential signaling technique. Now next we have 802.4 standard. So if we want to use 802.4, then the topology will be bus, tree, or star. but the medium access, how the different nodes connected or computers connected in bus, tree, or star topology, they will access the medium, LAN transmission medium, to send the information. It is token bus. Now, in token bus, here also, just like token ring, prior to transmit information, a token is being circulated in a ring network. Here also, though it is bus, tree, or star topology, not a ring topology, a token will be circulated within the LAN transmission medium, and the station which will have an information to transmit, it will take the token, and then it will transmit its information, and then when the data is being sent, it will release the token, so that other station will take the token to transmit its information. But here in token bus, though the it will be information transmission follows logical ring, not the physical connection of the node. Now, say here, this will be the physical topology of the bus. Now, here the address, these are the address of the stations. Now, these stations, which has an address 128, it is connected here, and the station which has an address 81 is connected here, and in between we have all these stations. Now, first, the token will be circulated in the bus, and the station which has information to transmit, it will take the token. Now, from here, if 30 station 30 will get the token first, then in case of actual token bus protocol, what is being used in a dual bus system, in case of bus topology, there this station, since it is nearby to this token, so it may take the token. But so here the token is not taken by each station according to the physical connection of the nodes. It will follow logical connection. That means if 30 takes the token first, then 081, then 182, then 156, then 950. So in this way, the token will be circulated within the bus, which is using 802.4 standard, which uses bus, tree, or star topology. Clear? No, here, there, it will be according to the physical topology, not the logical one. No, the station which will take the token first, that whether it is a lowest order address, whether it is an highest order address, which the station which has taken the token first, that will transmit the information. In case of token ring protocol, because this token bus is equivalent to token ring protocol, but it is not a physical topology, it is logical one. There are any stations which have information to send, that can take the token first. Clear? Here, any station, say if 128 will take the token first, after 28, which station will come, then 156, then 950, then 30, sorry, then Yes, it will be next station, then 30, then 81 in this way. So this will be it will follow in this way. If 156 takes first, then 156, then 950, then 30, then 81. If 30, then 81, 128, 156, 950. The token will circulate in this way. Clear? And here I have written all the points. When I will send the note, you will study that. Now the physical layer here, in case of 802.4 standard, broadband coaxial cable, and the data rate will be 1, 5 or 10 Mbps. If it is optical fiber, then the data rate will be 5, 10 or 20 Mbps. Now again for the next one, 802.5 standard, here topology will be ring. So 802.5 and 802.3 is specified. The MAC protocol for 802.3 will be always CSMACD, and for 802.5 it will be token ring. And the physical layer will be shielded twisted pair at 4 or 16 Mbps, here using differential Manchester. And if it is unshielded twisted pair, then it will be 4 Mbps and differential Manchester signaling technique, because it is unshielded, so the data rate can't be made to 16. It is always at 4 Mbps. In this way, we are going to categorize the IEEE 802 committee has categorized the LAN. Now there will be 802.12 standard or 0.12. There here the topology ring, but here round robin priority is used. Now here each station connected or each node connected in a ring has given a particular time slot to transmit its information. If it is not able to transmit information within that particular time slot, the token will be passed on to the next station. And how the token will be distributed, there will be a central node which will denotes which station will transmit first, which station will transmit next, and how the token, and in this way token will be circulated. That is being totally decided by the central computer or central node. If it is central, then we call it centralized system. Now if it is distributed, then all of the stations have given a particular time slot, say T1, T2, say T1 for first station, T2 for second station, T3 for third station. Then it distributed means after T1 will transmit, then T2, then T3, and so on. Now, and this is useful if all of the stations or most of the stations have information to send. Now next, for again in 802.12 standard, we have Fddi Lan, which is fiber distributed data interface. It is solely on fiber optic, and this has a topology dual ring. In dual ring, instead of single ring in ring topology, we have dual ring. One is blue one, another is red one. Now, now why we have dual ring? If there is a failure on the primary ring, then the secondary ring will take care of transmitting the information. and this will be the, if here it will be counterclockwise and here it will be clockwise in secondary. So we call it a dual ring. And here also protocol will be token ring, but it is slightly different. And this difference is been shown here, which is equivalent to early token release. Now suppose here the signal is transmitting, or token is circulated in a counterclockwise direction. Here the signal may be clockwise or a counterclockwise, and here we have assumed it is a counterclockwise transmission of signal or the token. Now say station A will take the token. Now it will transmit the data frame, and as soon as it completes the transmission of the frame, it will release the token. So at the end of transmission of the frame, it will release the token, so that the token will be circulated within the ring, and say the next station or the station which has an information to transmit will take the token. So at this there will be more data frames will be on the ring. In this way we are using ring utilization efficiency, as well as we are avoiding the collision among the frames. Clear? The difference between token ring, actual token ring, and the token ring what we have used in dual ring, which is equivalent to early token release, by which we can improve the performance of the token ring. Yeah, that is early token release, that I have told you to how could we improve the efficiency of the ring. But in token in dual ring, it automatically happens. Now come to the LAN addresses. And now LAN has both the destination LAN, destination node and the source node connected in a LAN, has a 6-byte address, and it is a 6-byte hexadecimal address. IP address ta ki bolo to? Ota ki hexadecimal na decimal? আর কত বিট? তোমরা সবাই কম্পিউটার ইউজ করছো, তোমাদের প্রত্যেকেরই আইপি অ্যাড্রেস আছে। ফর ইচ ইন্ডিভিজুয়াল কম্পিউটার উই হ্যাভ অ্যান আইপি অ্যাড্রেস।
ম্যাম ওটা জেনারেলি ডটেড ডেসিমালই হয়।
Yes, dotted decimal notation. Why decimal? Because decimal number, it is very easier to remember rather than hexadecimal address. We can we could, it is very difficult if the address is ABFF 81 and so on, but we could easily remember 10 11 12 13, isn't it? So the IP address will be a 32-bit decimal address, whereas LAN address will be 6-byte, which or 48-bit hexadecimal address. And these addresses are of 3 types: unicast, broadcast, multicast. Now when the sender of the node uses unicast address, that means it is meant, the information is meant for one or single receiving end station whose address is mentioned on the MAC frame. Because when we are going to study MAC frame next, there we will see that there will be a provision for source address as well as destination address. Otherwise, it is very difficult for us to send the information. Because if it is a bus LAN, I have told you bus is a broadcast, their information transmission is broadcast in nature. So if the station address is not being mentioned, the all the stations connected to the bus receive the information. So we have to categorize the LAN addresses Unicast means if the LAN node uses a unicast address, it is meant for a particular station or a single station. If it is broadcast, then it will be available for all the stations connected in LAN. And if it is multicast address, then some of the nodes are grouped together and then given to a multicast address. And what will be, how the, for unicast address, what will be the bit, and for multicast what will be the value of the bit, that has been mentioned in a MAC frame. When we are going to study this, we will see that. So when node sends a packet, unicast address, the packet is meant for one node specified by that address, and broadcast all the nodes, and multicast group together and give a multicast address. And then all the station having the multicast address will receive that information. And this address is being mentioned in the network interface card, the NIC I have told you. It is accept, unicast and broadcast address. And to do that, for using multicast, we have to write a program. Now MAC addresses says 01, 23, 45, 67, 89 AB. This can be written as within by dash or by colon. These are hexadecimal: 01 hex, 23 hex, 45 hex, 67 hex, 89 hex, AB hex. If it is a MAC address, and if it is a broadcast, all are FF. Now these are the 6 bytes address. We have either source address or destination address, source node or destination node. Now here the 6th byte, this will be the 6 bytes, and it will have 8 bits. And if the LSB bit will determine whether it is an unicast or multicast. If this bit is 0, then it is unicast address. If this bit is 1, then it is multicast. Then next bit, it will determine whether the local vendor who is supplying the LAN for us, if it is 1, then it is logically administered, and this address is given by the local vendor. And if it is 0, then it will be decided by IEEE, global address administered by IEEE. Now this is the MAC frame. Here first one, this is the preamble, then SFD, start of frame delimiter, then destination address, source address, length of the data field, which includes LLC data plus pad, and then FCS is the frame check sequence. Now preamble, this has been used in and these together is known as IEEE 802.3 medium access control frame format. So the data frame which has been circulated in CSMA-CD protocol by using CSMA-CD protocol, token ring protocol, token bus protocol, that frame is known as medium access control frame in case of LAN. And this the preamble, this length is 7 bytes. Here a particular bit pattern is being sent from the sending end side to the receiving end side, and this bit is being used, and of 7 byte which is 8 into 7, 56 bit long, to provide a synchronization between the transmitter and the receiver. Clear? 56 bits, 7 into 8. So there will be a particular bit pattern, and this bit pattern will be 01, 01, 01 up to 56 bits. Clear?
Yes, ma'am.
Now, start of frame delimiter. This is used to include the start of the MAC frame, because actually DA, SA, length, LLC data, pad, this will includes the actual start of the MAC frame, because LLC data and pad, this will contains the actual information. Now, so the start of frame delimiter, it is an 1 byte or 8 bit. So this after we are going to send this bit pattern, then the bit which is being sent, that bit will be if counted as a start of the MAC frame. So after SFD, if there is a bit, so that will includes first the destination address, then source address, then the length, then the LLC data, then pad, then FCS, in this way. So it will this enables the receiver to locate the first bit of the rest of the frame. Destination address, it is, I have already told you, Mac has LAN has 6 byte address. So this is 6 byte, this is also 6 byte destination address, source address. And length, it will includes is 2 bytes, so it will denotes us the length of the LLC data plus pad. Now the LLC data, it is variable, but the maximum size will be 15, maximum size of this data will be 1500 byte, and minimum will be 46 bytes. And then this is the frame check sequence used as a 4 byte or 32 bit. So here we are using 32-bit polynomial, which is CRC, cyclic redundancy check. Here we are using polynomial code. So 32-bit polynomial code we are using to check whether there is a error in the data or not. And this FCS is being done on DA, SA, length, and LLC data and pad. So here calculated based on bits, on all the bits except preamble, SFD, and FCS itself. So this will be the different field of the medium access control frame, and the total length together with preamble, FCS, SFD, it is 1526 bytes, because LLC data, LLC plus PAT field, this will includes maximum of 1500 bytes, and besides the length will be 7 plus 1 8, 8 plus 6, 14, 14 plus 6, 20, 20 plus 2, 22, 22 plus 4, 26. So 1500 plus 26. So the length of the MAC frame will be 1526 bytes, because from here to here, this is the MAC frame. Clear? Hello?
Yes.
Now come to the Ethernet LAN. Now this Ethernet is a trade name given by given to the LAN, local area network. If the local medium of transmission medium is a coaxial cable, and the diameter of the coaxial cable will be 1/2 inch, and it will be 500 meters long. And this trade name has been given by Xerox, Intel, and Digital Equipment Corporation, or DEC, and it obeys 802.3 standard. So the Ethernet LAN, by Ethernet LAN, this is a trade name um, for given by the actually topology is bus, and it is the trade name given by the Xerox, Intel, and Digital Equipment DEC Corporation, because there the coaxial cable that has been used as a medium, that medium they called ether. That is why we call it Ethernet, and it is bus topology 10 Mbps data CSMA CD LAN. Now there will be also the Ethernet LAN has the following specifications: 10 Mbps. If it is 10 base 5, then it is the medium is coaxial cable signaling baseband signal, but using coding technique Manchester topology bus, and nodes, number of nodes connected can be connected to that LAN is 100. That means we can able to connect 100 computers. If it is based on 10 base 5, that means within 500 meters length we can connect 100 nodes. If it is 10 base 2, it will same as that, but here the number of computers or nodes that can be connected is known as 30. 10 base T, here it is unshielded twisted pair. Baseband Manchester, the topology is star, and here the nodes is not being specified. 10 base F, here this is a 800 nanometer. That means the wavelength of the fiber, because the light signal is passing through the fiber, and what will be the wavelength of that light that has been specified, it will be 850 nanometer. Signaling Manchester or on-off signaling technique. On-off means 0 is represented by 0 volt signal, or uh, off is denoted by, that means when the light is off, 0 is being transmitted, and when there is a light, 1 is being transmitted. And the topology is star, and the number of nodes that can be connected is 33 for 10 Mbps Ethernet. Then we have a 10 base T specifications. This is a 10 Mbps. 10 base T, it is unshielded twisted pair, star shaped topology, link limited to 100 meter on UTP. If it is optical fiber, 500 meter. And here the multiple level of hubs can be cascaded. So these stations, this is connected to this hub, and these 3 hub together with the station can connected to higher hub. This is lower, and this is higher. Multiple levels, this is a level 1, say this is highest level, in this way. Now we have a 100 Mbps. It is called fast Ethernet because data rate will be high. And we have here 100 base TX, 100 base FX. TX stands for unshielded twisted pair, Cat5 UTP, and 100 base T4. Here we have Cat3, 4, 5 UTP. And the signaling technique here is MLT3, both shielded and unshielded. Here it is unshielded, Cat345, and NRZ and NRZI. Now here we have seen how the nodes are being connected. Then gigabit Ethernet physical specification, 100,000 base LX. This is all on fiber, and also unshielded twisted pair cable or shielded. Then the distance here will be less than that of the fiber. This is the maximum distance that can cover the transmission. This is gigabit Ethernet. Then we have a 10 gigabit Ethernet. Here 10 gigabyte can be sent. That is why we call it 10 gigabit Ethernet. And short means short wavelength, long means long wavelength. So here wavelength is 850 nanometer, here 1310 nanometer. For extended, here we are going to extend the wavelength from 1310 to 1550. And here it is on again single mode fiber. This is single mode fiber, but this can be on multi-mode fiber. And 100 base 10G base LX4, this is 1310 on single mode or multi-mode fiber up to 10 kilometer. So these are the specifications given by the IEEE 802 committee when the LAN has been incorporated anywhere. And then hubs and switches, I have already told you which what we mean by hubs, active hub and passive hub. And switches is nothing but the intelligent hubs. So let me finish here today. Okay.
Okay,
Have you
ma'am.
understood all this up to this? তোমরা কত রিড করবে আমার জানা আছে। Okay, thank you very much for listening.
Thank you, ma'am.
Okay.
Thank you, ma'am.